Hey, everyone. Okay, we're going to get started in just a minute. Let me get all my things set up here. Also, I need to make sure that you can hear me. Sorry, I should have done this before hitting go live, but that's okay. If you are here, please say hello. I am just streaming on YouTube today. Then I'm going to repost this on Facebook. Last time with trying to stream on both, I didn't really care for the quality of the video too much. And I don't know, I just haven't found the right software to help me stream that I feel is like a reasonable price. I don't mind paying for, that kind of thing, but yeah, it's a lot. So we are going to get started here. All my pages up that I need over here. Also, let me start sharing my screen too. This just looks so much clearer than when I was using the other software last time. So that that's where we're at right now. We're going to be going over SAT and PSAT questions today. So I'm going to be doing that through mid-March because I believe the SAT is March 14th, the spring SAT, which I know is the one that most people will tend to take. So I thought we would cover some SAT topics as well. All right, just checking my sound here real quick. All right. Okay, got it. All right, well, let's go ahead and get started. We're going to go in all of the worksheets that I'm working off of are in the printable, SAT practice. So this is the link. I did put the link in the description, so you can check out the description and the link is there. We are doing the PSAT 8-9 Bundle 1, and we're starting with Module 2 today. So we're doing Module 2 for both. I figured Module 2 is probably the one that is, I don't know, maybe not covered as much. People will just start with the first module. So I went ahead and skipped down to Module 2. You can use a calculator on the SAT, so I'm going to have my calculator handy. But if you would like to go through those with me, then that is where you can find them. All right. This already. I'm also going to just go through and kind of show some common pitfalls, some common mistakes that students will make, and also like with any of these types of tests, they are built to trick you. They are made in a way that, let's say you're working through a problem that has multiple steps to it. One of those steps, like whatever you get as the answer for one of those like initial steps, will almost always be on on here as answer choices. And it's by design. So I kind of hate that about standardized tests, but that's where we are. All right. Let's go ahead and start in on this first problem. So we've got, and please feel free to say hello in the chat if you're here. There are 20 buttons in a bag, 8 white buttons, 2 orange buttons, and 10 brown buttons. If one of these buttons is selected at random, what is the probability of selecting a white button? Okay, so this is a classic probability question. Whenever we're looking at probability, we want to know, it's usually in fraction form. So the fraction will always be the option of success, like how many options are there to succeed at what it is that we're looking for out of the total, in this case, number of buttons that are in a bag. And that includes the number that is the success as well. So if we are looking at the total, we want to include the white buttons in that total number as well. So they're telling us though that there are 20 buttons in a bag, so we don't have to count. If if they didn't tell us this part, we would have to add up all of the number of buttons, which does equal 20. But this is one of the areas where students will make a mistake. They won't count the white buttons in the total. So the total, they might just write 12 because that's the number of orange and brown, which are the buttons that are not including the white buttons. But we do want to include all 20 of those in our denominator. And then what is the number of for the success of selecting a white button? So we've got 8 of the make this true, I guess is a way to say that. Is that oh, hang on, it's saying the connection is unstable. Hold on. Mm, you know what? Sorry. Give me just a second. Let me maybe close down some of these other tabs that I've got open. Just in case that's what's causing it. I mean, our internet quality is pretty good, but, with 3 people living and working here, that tends to happen sometimes. Where am I? There we go. Okay. Alright, so, in this case, we do see 8 out of 20 here, so that would be the correct answer. You might need to simplify this fraction, so if you don't see this fraction exactly the way that it is, then simplifying it, you might see that as one of the options. Alright, let's go down to problem 2. An employee at a restaurant prepares sandwiches and salads. It takes the employee 1.5 minutes to prepare a sandwich and 1.9 minutes to prepare a salad. The employee spends a total of 46.1 minutes preparing X sandwiches and Y salads. Which equation represents this situation? Okay, let me pull out my highlighter here. We've got 2 different things that the employee is making, right? And it takes them a different amount of time to make each thing. So what I wanna highlight here is it takes 1.5 minutes to prepare a sandwich, and then down here, it tells us what variable they want us to use to represent those sandwiches. And then separately, they tell us that it takes a different amount of time to prepare a salad, and then again, they're telling us down here what variable they want us to use for salads. Whenever we are, um oh, I'm sorry, I forgot to highlight the total time. So it takes them a total time of 46.1 minutes to prepare those X sandwiches and Y salads. Remember that these variables just stand for numbers that we don't know. We don't know how many sandwiches they prepared or how many salads they prepared, but we know that they prepared some number of sandwiches, and for each of those sandwiches, it would take them 1.5 minutes. So that tells us multiplication, right? Because for 1 sandwich, it's gonna take them 1.5 minutes. For 2 sandwiches, we would multiply 1.5 times 2 to get the total amount of time to make those sandwiches. And then the same thing for Y. So what I'm looking for in our answer choices is that 1.5 multiplied times the X and the 1.9 multiplied times the Y, and then those 2 amounts added together. So I see that right here in solution B, the 1.5 times X plus the 1.9 Y, and then that does equal their total time of 46.1 minutes. Okay, so B would be the correct solution for that one. Let's go do that like that. Number 3, in a box of pens, the ratio of black pens to red pens is 8 to 1. There are 40 black pens in the box. How many red pens are in the box? A couple of different ways that we could look at this and solve this. I really like tables whenever we're talking about ratios and proportions because it just kind of sets up those two fractions. Whenever we're trying to solve one missing part of a proportion, it sets it up for us so that we know exactly where those numbers are supposed to be in those two fractions. So let's go ahead. We'll do we'll do black pens and red pens. I'm just making a table here. And then this is the ratio number, and then this is the actual number. So now we're just filling in the blanks. What is it that they told us? And also with ratio, the order here matters. Because they said black to red, then that means that 8 goes with the black pens and the 1 goes with the red pens, okay? So because black is first and red is second, 8 is first and 1 is second. So that's how I know that that's what numbers go with each color of pen. And now they're telling us there are 40 black pens. Okay, so now we have an actual number of black pens, but we don't know this one. So because we've set up this table, these are our two fractions here. This one and this one are our two fractions that we are going to set up side by side. 8 over 1 is equal to 40 over, you can put question mark, you can put X, whatever, just a variable. We don't know this number. And then these are equivalent fractions. So this one's pretty easy just to use multiplication to get from one fraction to the other because we can see that 8 times 5 is 40. So then we would want to do that same thing for the denominator. 1 times 5 is going to give us X, our missing number. And in this case, it is going to be 5. Now, if this wasn't if this didn't go in evenly, we couldn't just multiply. Another way to do this, just set this up again. Another way to do this is to cross multiply. Go back to my darker pen. We're going to cross multiply. We're going to multiply diagonally. 1 times 40 is 40, and that equals 8 times x is 8x. And then we divide by 8 in order to solve for x. X equals 5. Okay, so that's the other way that we can do it, and you can see that we got the same answer both ways. Let me move that so that's not in our way for our next problem. All right, number 4 here. We've got the function f is defined by the equation f of x equals 100x plus 2. What is the value of f of x when x equals 9? This symbol right here, before we even get into how to solve this problem, I want to explain this symbol right here because a lot of students think, and rightfully so, I mean, like it makes sense, think that this is saying the variable f times the variable x. I mean, because that's what it looks like. That's what we've learned, that whenever there are two variables or a variable and a number just squished together, or one's in a parenthesis and one's not, that means multiplication. However, this is just a function notation. F of x, whenever you see it like that, first of all, that's how you read it, f of x. This is just another name for y. So all of this can be rewritten as y equals 100x plus 2, okay? And all that this means is that we substitute in a number for x, what would y equal? Or what would f of x equal? Okay, so that's really all that we're saying here. It's just written in a different way. Okay, so let's actually take a look at that. So it says, what is the value of f of x? Remember, f of x is just another name for y when x equals 9. So we're just substituting in 9 for x in our equation. So I'm just going to write it as y, 100 times 9 plus 2. And then y equals, we're going to use order of operations to solve this. So 100 times 9 is 900. And then y equals 900 plus 2 is 902. So y, or if we want to write it as f of x equals 902. That is the value of f of x. So we're looking at D there for our answer. Okay, let's go on to number 5. The length y of a white whale was 162 centimeters when it was born and increased an average of 4.8 centimeters per month for the first 12 months after it was born. Which equation best represents this situation, where x is the number of months after the whale was born and y is the length in centimeters of the whale? Ooh, that's a lot of information. Okay, so what are we saying here? We're saying that the whale is born, okay? Once it's born, it's 162 centimeters. And then it increased, it grew, right? Because that's what whales do. They grow as they get older. It increased an average of 4.8 centimeters per month. Whenever you see a number that is per or each, something that is happening over and over and over again, then that means that that number is going to be multiplied times a variable, typically, especially when we're talking about equations that have two different variables like x and y, like this one does. And look at our answer choices. All of our answer choices have y equals, and then there's some x in each of these choices. So that's what we're looking for. We're looking for that 4.8 to be multiplied times x because um, it says right here where x is the number of months after the whale was born. So that means that whatever this x is, we can just substitute in the number, like the number of months after the whale was born. So, like, let's say we want to know how long this whale was 6 months after it was born. We would be able to just substitute in 6 in for that x and multiply it times 4.8 because we know that each of those 6 months, the whale grew 4.8 centimeters. Okay. The difference is that here we're adding 4.8 and here we're adding 162. Well, how much length, like how big was the whale when it was first born, right? It wasn't 0, it wasn't 0 centimeters. It was 162 centimeters. That they told us that when it was born, it was 162. So that's our starting point right there. And then after that 162, we're adding on 4.8 for every month that the whale was alive for the first 12 months of its life. So we've got D right there. Okay, we're going to go on. I do have one more page. I'm going to try, let's see. I wasn't sure how long these were going to take me to get through. We're already at 20 minutes. I do kind of want to get through these just to make sure that we get through all of module 2 by the end. Um, so I do want to try to get as much in here as possible. So yeah, let's try to get through some of these and then we will, I do have the SAT next. I've got 2 pages of that as well. All right. Let's go on to number 6 then. We've got the perimeter of an isosceles triangle is 83 inches. Each of the 2 congruent sides of the triangle has a length of 24 inches. What is the length in inches of the third side? So let's give ourselves a visual here. An isosceles triangle is a triangle that has 2 sides that are congruent to each other, and then the third side is something different. Usually, there's some technicalities about an equilateral triangle is also an isosceles, but we're talking about a triangle that has 2 sides that are congruent because it tells us here each of the 2 congruent sides of the triangle has a length of 24 inches. Perimeter perimeter, we would just add up all the sides, right? So it's telling us that the two congruent sides is 24 inches. So that's these. And then this one is, I don't know, we don't know what it is, but we do know that if we add up all three of the sides, I'm just going to use X for the third side, that it should equal 83 inches because that's how we find perimeter. So then perimeter equals 24 plus 24 is 48 plus X equals 83. And then we're going to subtract 48. I shouldn't have wrote it like this. Hold on. Let me get rid of this. I don't want two equal signs in there. That's not really what I meant. This is the perimeter, so I substituted in 83 for the perimeter, and these are the three sides that I'm adding up. Sorry, I don't want to make that confusing. So then X equals, and then what do we have here? We have 35. So our missing side length is 35 inches. There's no multiple choice on this one, so this is one where you would just have to type in your answer. All right. If 2 plus x equals 60, what is the value of 16 plus 8x? So we've got an equation and an expression. In order to solve this expression, we would need to know what x equals. We can't figure out what x equals just with an expression, but we can with an equation. So this is just a matter of solving for x. And they're saying that x equals the same thing in both of these. So we just need to solve for x. So 60 minus 2 is 58. And then we're going to substitute that into this one. So we're basically doing two different problems here. Luckily, it's not too challenging. And I am going to use my calculator for this one. I don't happen to know what 8 times 58 is off the top of my head. 464. 16 plus 464. We're going to add 16, which gives us 480. So again, this is one where you would just type in the answer for that one. All right, number 8. Population density of Worthington is 290 people per square mile. Worthington has a population of 92,800 people. What is the area in square miles of Worthington? Okay, so they're telling us here that per square mile, for each single square mile in this city, there's 290 people. And then they're telling us how many people are in the whole city. So this is a table. We're going to make a table just like we did in one of those other problems. So we've got people and we've got square miles. Those are the two pieces of information that they're telling us. So the first one is the unit rate, right? For 1 square mile, there are 290 people. And then they're telling us the actual numbers. So Worthington has a population of 92,800. What is the square mileage, right? So again, we've got that proportion and we've got our numbers set up so that we don't make any mistakes about where to put the numbers in our equation. I'm going to guess that this is evenly divisible. So in order to get from 290 times what equals 92,800? Well, I'm going to kind of work backwards and divide. So I'm going to do 92,800 divided by 290. Okay, so that gives us 320. So times 320 and 290 times 320, and you can put that in your calculator and verify that, equals 92,800. So we're going to do that same thing here, times 320, and then 1 times 320, it's just 320. I really like this method, even though this was a simple one that we could have just divided from the very beginning, just to make sure that we are doing the right operation. All right, last one on the PSAT, and then we're going to move on to SAT. So in this one, what is the y-intercept of the graph shown? So we've got a graph here. Our y-axis is this vertical axis right here. And the intercept is just where does the graph cross through that axis? So we can see that is happening right here at -6. All of our answer choices are in coordinates, so we just need to make sure that we're choosing the right one. Remember that our y value is the second number in a set of coordinates. So if we're starting here at the origin, we don't move left or right at all, which would be the first number, but then we do down 6 units. So A is what we're looking at for that one. All right. All right. Let's go ahead and get into our SAT prep. And again, this is from College Board. You can go, links are in the description. This is SAT Bundle 4. It'll be in the printable section of the collegeboard.org website. And we are working through Module 2. And I've got 2 pages for us. So let's get into that. Sorry. Just checking on something over there. Let's start with this first problem. Scoot this up a little bit. The line graph shows the estimated number of chipmunks in a state park on April 1 of each year from 1989 to 1999. Based on the line graph, in which year was the estimated number of chipmunks in the state park the greatest? So we're looking at this line graph. We've got the years down here on the x-axis. We've got the number of chipmunks on the y-axis. So we're looking for that highest point on this graph. So right here, we see this highest point, and they're asking which year did that happen. So it looks like we're looking at 150, maybe 150 plus chipmunks, but the year corresponds to 1994. So that is that one. Oops. Okay, let's see what we've got on problem 2. A fish swam a distance of 5,104 yards. How far did the fish swim in miles? And they're giving us a conversion. 1 mile equals 1,760 yards. Okay, so then we have to, we've got our conversion here. I like to do this method where we're first figuring out, are we going from a larger unit of measurement to a smaller unit of measurement, or a smaller to a larger? This is a little strategy that I've used with a lot of my students to help them remember if we are going to multiply or divide our numbers. So, a yard is smaller than a mile, right? So we're going from yards to miles. And so when we are going from a smaller number to a larger number, we're going to divide. So I'm just going to put the division symbol there. And then where I'm going to write out my division problem. So we've got our yards of 5,104 divided by 1760. And let's see what that is. So that comes out to be 2.9, which is one of our answers right here. So selection B. All right, on to problem 3. Which expression is equivalent to 12x cubed minus 5x cubed? All right. We do have like terms here, and we can see in all of our answer choices, we do just have a single term in all of our answer choices. So whenever we have like terms, we are going to perform the operation on the coefficient only, and then that term, the variable and its exponent is going to stay the same. So 12 minus 5 is 7, but then we're gonna keep it as x cubed. I think that's looks like that's what they're testing here is what you would do with with the exponent. All right. Moving pretty quickly on this page, so I feel like we're gonna, not be too long on this video. What is the solution, xy, to the given system of equations? So take a look at our answer choices. They are all coordinate pairs. And let's take a look at our two different equations. We can choose whatever method we would like to use for system of equations. There's graphing, substitution, and elimination. This one seems like a great candidate for substitution because this equation has just a single x on one side of the equation. If x equals 5y, then x equals 5y in this equation too. So I can take this top equation and substitute in 5y for x. And now I have an equation with only one variable, which is solvable. It's not solvable before when we have two different variables in the same equation. So that second equation helped us know what x is equal to in terms of y, so we can substitute it. So then we just need to solve. 5y plus y is 6y. That equals 18. Divide by 6, divide by 6. So y is going to equal 3. So now remember that for a system of equations, a solution is a coordinate. So we need two different pieces of information. We need the x and the y. We have the y. Looking at our answer choices, this is the only one with 3 as the y value. So I'm pretty sure that's going to be the correct answer, but I'm going to go ahead and solve for x as well. And you can put in either of these equations. I'm going to go ahead and choose the second equation and substitute in 3 for y, because now I know that y equals 3. And 5 times 3 is 15. So now 15 does equal x, and that does match up with this solution right here. All right, cool. Let's go on. Okay. We're going to finish up this last page here. Again, I'm trying to get through 2 pages for each module per week because we have about 4 weeks before the SAT. I actually need to check on the dates for the I know that PSAT, you typically take that, like, at school, and they offer it at different times during the year, so, I know the SAT is kind of like um, I don't know, the one that, that colleges look at and stuff, so carries a little bit more weight to it. All right, so let's take a look at number 5 here. The point 82 in the xy plane is a solution to which of the following systems of inequalities? All right, so let's just take a look at our answer choices here and think about our coordinate grid. So if x is greater than 0 and y is greater than 0, that's positive x. Oops, let me write it over here. Positive x and positive y, right? So that's going to be in this quadrant 1. If x is greater than 0, but y is less than 0, so that's gonna be x is greater than 0, y is less than 0, that's gonna be down here. So that's a positive, negative. And then if x is less than 0 and y is greater than 0, that's gonna be a negative positive, right? So that's gonna be for C. Let me label these. This is what A is representing. This is what choice B is representing. This is what choice C is representing. And then D, x is less than 0, y is less than 0. That's going to be down here. That's a negative, negative. So this is what choice D is representing. Our point is a positive, positive. I know I didn't have to go through all of that, but just so that it's very clear. So if we have like 8, 2, I don't know, something like that, if that's where our point is, then it's gonna be in this first quadrant right here. So we're looking at choice A. Okay, number 6, we don't have a multiple choice on this one. We've got the absolute value of x minus 5 equals 10. What is one possible solution to the given equation? Okay, so there are going to be 2 different solutions to this equation, but they're just asking for one. We're gonna go over how to find both. Whenever you have the absolute value, and this absolute value is by itself over on one side of the equation, so we don't have anything that's, like, being multiplied times it out here or anything that's being added to it on the outside of those absolute value bars, then we want to, at that point, split it up into 2 problems, where we've got x minus 5 equals 10 and x minus 5 equals negative 10. Now, this part can get really confusing because kids are like, my students I work with are like, why do we just change this 10 into a negative 10? Remember that the absolute value, we're asking for the distance away from 0. So with distance, with that kind of measurement, there is no negative distance, right? You can't travel negative 10 feet. However, so that means that if what is inside of here equals 10, then it's going to equal positive 10. If what's inside here equals negative 10, the absolute value of that is still positive 10. So we need to test out both scenarios. These are just scenarios of what this x minus 5 could equal, um, so so that it would equal negative 10, sorry, positive 10 or negative 10. Either of those options would give us a negative 10 once we take the absolute value. So notice that we don't have the absolute value bars on these anymore. All right, so let's go ahead and solve. We're going to add 5 to both sides on this one. So this gives us x equals 15. We're going to add 5 to both sides on this one. So this one equals x equals negative 5. And those are our 2 options. So either of those would be acceptable solutions for this equation. Number 7, the function gives, sorry, f of x equals 7x plus 1. If you're here watching for the PSAT, remember that f of x is just another name for y. It doesn't mean f times x. We're not talking about 2 different variables here. The function gives the total number of people on a company retreat with X managers. What is the total number of people on a company retreat with 7 managers? Well, they just told us here, this is why I underlined this. They just told us that X represents the number of managers that's on this retreat. And now they're telling us, well, what if that number is 7? So we simply substitute in, when we write it like this, f of 7, we're just saying, well, what do we get when we plug in 7 for x? And we're just solving this side of the equation. Nothing happens over here. So 7 times 7 is 49. 49 plus 1 is 50. So f of 7, when there are 7 managers, then the total number of people that are on the trip is 50. Just a couple more problems. Okay. Let's go to problem number 8. H of x, again, it's an H, not an F, but it's still the same thing. This is just another name for y. So H of x equals x squared minus 3, which table gives 3 values of x and their corresponding values of h of x for the given function. So, I mean, hopefully these tables kind of give you an idea of what we're looking at. We've seen a lot of XY tables. And that's exactly what this is. It's just not called Y anymore. They're using H of X. So basically what we're doing is we're looking at these X values. It's like 1, 2, and 3 for all of the tables. The only thing that's different is the H of X values on the second row of values. So with these, what I like to do is look at my answer choices. I can see that if I substitute in 1, they've got 3 different values for me that it could be. It could be 4, it could be -2, it could be -1 because then -2 is, like, repeated here again. So let's go ahead and substitute in 1 into this, um, function and see what we get. So we've substituted in 1 for x, so 1 squared is 1, and then 1 minus 3 is -2. Okay, so that tells me that these are my 2 options, A and C are out. So then I'm gonna look at my next option. Well, this is the same in both of these. So by plugging in 2, I'm just doing extra work. It's not gonna give me any, new information. So here I see that this is different for when we substitute in 3, if I substitute in 3 for x. So I'm gonna skip to that one. So we're gonna do h of 3. So 3 squared minus 3. 3 squared is 9, and 9 minus 3 is 6. This is the one that gives me 6 for h of x when I substitute in 3, so B is our correct solution. Alright, last one. A lot of functions in here. The function f is defined by f of x equals 270 times 0.1 to the x power. What is the value of f of 0? So, notice they didn't say when x equals 0, but that is what this question is asking for. Whenever they've replaced x with a number, that's what they want you to do in this other side of the equation. So we wanna know what f of 0 is, and so instead of x as the exponent, we're substituting in 0 for x. Alright, so then let's solve this. Anything to the 0 power equals 1. So this is the same thing as 270 times 1, which is just 270. So we're looking at answer D for that one. Okay, I hope that all of that was helpful for you. If you, have joined me on the replay on Facebook or on YouTube later on, then please drop me a comment below. Let me know what you thought. After I get done, going through all this SAT practice through March, I'm going to determine if I'm gonna still continue doing the live streams. I'm hoping that they'll create a little bit more traffic for me on YouTube, and I'm hoping that I'm hitting the mark with, finding skills that will be most helpful for students, like, as they're going through school and finishing out the rest of the school year. So some feedback would be really helpful for me, just letting me know what it is that you're working on at school so that I can, um, cover some of those skills here and give you guys a little bit of free help. So, thanks again. Thanks so much for watching. I do really appreciate it. Sorry, I'm just looking at my page over here, and it looks very, like, washed out. I'm not sure. But yeah. Anyway, thanks so much for watching. Let me know what you thought in the comments, and I'll see you next week. Bye.